scholarship information, any additional. Spark Tech coming back. Everybody's interested in Spark Tech.
You do things now.
Denver mascot design event for the course of November, all month. All teams are welcome to participate in designing mascot products. Stop by the light pursuit, receive a mascot design. Seniors, log on to Booth this week. Voting for your class song. Motto.
Yes.
In color. Thank you. Starting today, ending 3/15 on Thursday. Ball play didn't say it was on it, happening soon, Thursday and Friday performance, 7 p.m. So theater, admission to the evening performance, $3 for kids, $5 for adults. Activity passes are accepted. There'll also be a matinee performance. Featuring understudies on Saturday too. Matinee is food inspection. If you're interested in taking the AP exam this spring, you can sign up for Counseling Office by November 4th. $96 to take that exam. College is here this week. We got college today when the county is over lunch. Tomorrow we have Sheridan, Dakota State, Northern State, South Dakota State University, and August Savannah will all be in the county coming. I congratulate our November senior students of the month. Morgan Miller, Clayton Donovan, and Callie Radenberg. Be a cheer meeting for anyone wanting to cheer for basketball season tomorrow, 2:05 in the cheer room. There will be paperwork that you need to complete. Impact testing for wrestlers, Tuesday, November 2nd, also in the cheer room after school. For any wrestlers that are freshmen, juniors, or new to the district that have not had one this year. You can bring your computers with you after school on Tuesday. Also, a meeting upstairs in the gym bleachers for anyone who is interested in wrestling, boys and girls wrestling, does not talk to Coach Potter. That's Tuesday after school. So please stand for the pledge. I pledge allegiance to the flag. One nation, under God, indivisible, with liberty for all. Have a great day and a great week. That's what I'm doing. You do it, I will do it. I'm telling you right now. Yes,
I take all the chatter to mean we're done. So let's get started. For each of these, I hope that you wrote down not just your answer, but what you typed into a calculator to ensure that if we goof something, we get partial credit. Or are we not actually done?
We're not actually done.
I know you're not.
Yes, sure.
No, she put it on like the thingies on her person.
As the last few are finishing up here. Reminder that I took care of your stuff first, last reporting period. So you all got put on the back burner this time. I have all other classes done. PreCalc, not so much. All your daily work was in, though, last week, or in my book anyway. I just got to put it on campus. It's just a matter of getting your last 2 quizzes done. Made sure to have all the other ones done, especially Algebra 2, since they got, like, their stuff was put in, I think, the night before, like Tuesday night. Yeah. So, fair's fair. Nice and simple. Formula plug and chug. You just got to know what the words mean as to what I put in the formulas and which formulas to use. Woo. Power of Christ compels you. I'm going to go to second. Quit. Get out of there. Clear all that out. All right. Blank screen say we're going to put $2,000 into an account with 5% interest rate because you never get that anywhere that is actually legal. Find an amount in the account, assuming no withdrawals or deposits, after 18 years. If compounded biannually. We talked about the difference between biannually versus semi-annually. If it is biannually, how many times is it compounded each year? A half. Semi-annually happens twice each year. Biannually happens every other year. So in a year, it would happen half a time. So we're going to head over here and grab our formula. What was that 2018 years? I'm going to say we got $2,000 times, times 1 plus my rate. My rate was 5%, 0.05, 2 places. I don't know. We're not in Algebra 1. They're doing stuff with percentages right now, so I'm over. There we go. Half a time, so I'll just say 0.5 instead of writing a half as a compound fraction. To the nt, in this case, 0.5. Seriously. To the, there we go. 0.5 times, and it says 18 years. So there's round 1. For round 2, same thing, except now we're going to switch it over to quarterly. So it's going to happen 4 times a year. 4, get rid of my little bitty decimal there. Poke. 4, poke. Everything else is the same. A little more. And what's different about continuous? PERT. So we're going to say, I like that because it sounds like Bert and Ernie. Hey, Bert. E to the, wow. Try that again. E to the, there we go. Rate is 0.05 times time is still my 18. There you go. So, that's exactly what you wrote. So I'm going to say 1 for the formula setup, 1 for the formula setup, and formula setup, triple answer. Please make sure that your answers are rounded correctly into monies. Okay. Ew. Yep. Think you have to say it with a little bit of that Valley Girl tone, though. Ew.
I have a question.
Hi.
So I did everything right except for my first one. I did semi-annual instead of biannual. So
So it was all of that except you have a 2 instead of a 0.5, which domino affects your answer, correct?
Yes.
4 out of 5.
Okay. Cool.
Anything else? Okay. You. So get rid of you. You. There we go. We have now had 70.5 hours. I received no questions. So, speak now or forever hold your pieces. Okay. That's good. I was hoping that we would be able to, like, have lots of time today. I know we're going to finish 3-2 and move into 3-3. I think if we can, and I do mean entirely we can minimize distractions because my brain's been all over the place lately. We might be able to get through the back half of 3-2 and 3-3 today. Because this is all review. Just depends how much you remember. So we left off with, we did definition of logs. We started talking about log properties. The two that you're going to use the most often, you can have a log of any base. It's asking this number as a base to what power equals thing. The most common bases to use, though, are going to be 10 and E. 10 because common log, our entire decimal system is based off of it. E because natural growth and decay, continuous growth and decay is something that happens oh so often, so we might as well give it its own name. They've got those properties that work for any log, but more appropriately, you got to remember that log base E gets its own name. LN, natural log. Log au naturel. Okay? And that is, oh yeah, that's right. I Frenched right, and then I wasn't supposed to say that. And we've come full circle. So what we do to make a log graph, pretty simple. I'm going to use all of that same stuff that I would for exponents. It's just going to be reversed. Inversed. X is Y, Y is X. I swap my domain and range. That means I swap my horizontal asymptote is now a vertical asymptote. All of the points that were there before, same difference. They're just flipped on their side. It's kind of like a square root function was to a parabola. These are going to do the same deal. It's going to take normal exponents and it's going to turn them on their side. So first we got to see, can you actually work with the properties? I want to throw something at you now. That smells amazing. Evaluating the expressions, you have to remember, if there is no base written, what base do we assume? Okay. So if I assume a base 10, this is asking 10 to what power makes this? Easiest way to do that is don't think of it as a decimal, think of it as a fraction. What place value is that 1 in? Remember, tenths, hundredths, thousandths? So if I say 10 to what power is 1/1000th, y'all remember how exponents work? Since 1,000 is 10 to the third, to bring it upstairs, I throw a negative on it. And then common sense tells me 10 to the is 10 to the negative 3, equals negative 3. So to evaluate them, if I know my properties of exponents, easy peasy. Part B, we kind of talked about this already. I'm saying up in the exponent, 10 to what power makes 5? Okay, now take 10 to that power. What are you going to get? 5. Okay, and that was one of our properties. It says that whenever I have a base and a log base that match, they cancel out. Now, part C. I can't repeatedly multiply together tens and naturally come out at a 26. In fact, it's going to be an irrational number. If I was to write it as a simplified answer, log 26 is as good as it gets. So I will then go find that button on my calculatron. Everyone know where log is? Okay. Log of 26. What place value do we go out regardless of what the book says? Thousandth place. Minimum 3 places. Okay. So approximately 1.415. And if you ever cut off part of the answer, do not say equals. Use the approximate symbol. Okay, you can't just say it equals this when it doesn't. And, like, just because I say it's a thing doesn't mean it actually is the thing. Okay, that would be like if I called Hannah, Jana for the rest of the year, just deciding to change her name because I felt like it. Like, I can't just do that. You can't just say it equals thing when it doesn't equal the thing. Okay, right over there. Throwing some shade at D. What's wrong with it? Thou shalt not take log of non-positives. We're finally at our third commandment of domain. So that one is just no. You can't do that. So, can you do this property of log's business with all 3 of them? But why? But why? You said 3C is not possible. Why? Okay. I mean, you can, just like you can always write a 1 in front of an X. It's not going to change it. A positive 0 and a negative 0 are still just a 0. It's a sign. You could have a plus or minus 0. It doesn't matter. It's not going to change anything.
Even if you did something to the 0 power, it's still 1. There's no way you can't do non-positives.
You can't repeatedly multiply together a number to get 0 other than 0 itself. So if I have a log base anything that's not 0, like, you tell me, how do I multiply together a bunch of 10s and get a 0? Okay, and you just can't. Because even 10 to the 0 power is 1. Over here I got out to the 10,000s. So that's log base 10 of 10 to the 4th. Okay. Or you actually set it up and say 10 to what power is 10,000. This one I'm going to have to run for my calculatron. And this one, my log and my base, my log base and my base of my exponent both match. So it cancels out. It's just a matter of pressing the buttons on that one. Say log of 0.081. Bloop. We round it off. Okay. Log properties, pretty simple. These are the most basic properties. We got some more fun ones. It's all of section 3. Hey, look, the exact same thing except E. If I have log base E of a thing, you just got to remember that when you see ln. This is saying E to what power makes E to the 0.73. Right? Same thing. 0.73. E to what power makes 6? I don't know, but if I'm going to take E to that power, I'm going to get a 6. Because this, ln of 6, this could be written as E log base E of 6. The base of the exponent and the base of the log both match, so it cancels out. Doesn't matter, just because it's log base E, natural log of -5 is still not allowed. And the ln of 4, well, go find that button on your calculator down here, ln of 4. Round it off and say approximately 1.386. Hey, don't do that. Don't do that. All right. Same thing, now there's just an E. Make sure you know your properties of exponents. Y'all are certainly better at this than my other classes, particularly the Algebra 1 sections. But please remember, whatever we're doing in class, if we writing up here, you're writing it on your paper. Also, you don't have to use the fill-in notes. If your jam is to have your own notes, that's great. Just has to be labeled, organized. I need to see example 4, ABC, practice 4A, 4B, 4C. Like, if you just want to do that in your own notes, your own way, go for it. I just print them out because in the past I just had this available online. And I told kids, look, if you want the notes, just print them. And they couldn't figure out basic printing instructions. So they would print it so it's like one big honking slide per page. And they'd hand in a stack like that. It was bad. So, Canceltown 4. That's the ln of e to the -3. So just -3 because Canceltown again. ln of 32, I'm just going to have to use my calculatron. 3.466. And negative ln of 9, am I allowed to do it? Yeah. Got a negative. Okay. Can't take log of a non-positive. The object can't be non-positive. This is perfectly legal. In fact, you can check that by saying if I did the ln of a -9, it would tell me no. All recalculations must result in a real number. You can't do that. versus I can have a negative ln of 9, no problem. Okay, that's going to come back up later when we're doing equations. Okay, so definition of logs, cool. Yeah. All right. Sketch and analyze the graph. Again, if I know how the exponential graph looks, I know how the logarithmic graph looks. I just swap all my x's and y's. Example. This is the inverse of what? Three to the x. Now I can prove that by using my definition of inverses. F of x becomes a y, swap x and y. Now use my definition of logs. 3 to what power makes y? 3 to what power makes y? Literally, I can show that this is the inverse of that. You don't have to write that part. I'm just showing you that this is just the inverse of 3 to the x. Well, if 3 to the x has a, you don't have to graph this part, I'm just showing the inverses, has a horizontal asymptote at y equals 0, and then is at 0, 1, 1, 3, 2, 9, negative 1, a third, negative 2, a ninth. If that's what its inverse looks like, I should be able to graph this log function by just swapping all of that stuff around. Instead of a horizontal asymptote at y equals 0, I'm going to have a vertical asymptote at x equals 0. Instead of hitting the point 0, 1, 1, 0. Instead of hitting the point 1, 3, I'm going to hit 3, 1. Instead of the point 2, 9, I'm going to be at 9, 2. Instead of negative 1, a third, I'm going to be a third, negative 1. A ninth, negative 2. And so on and so on and so on. Go away, go away, go away, go away. All right. Curls along my vertical asymptote, heads off into the wild blue yonder. And you should notice that it's still using 1, 3, 9. It's still using the powers of 3 because that's my base. Just take your powers of 3 and instead of doing the exponential curve, tip them on their side, like one of those goats that falls over. And just, there you go. Okay, powers of 3 on their side. I mean, I feel bad for them once you actually learn why they do that. It's a muscular contraction, like from being overwhelmed with sensory input. They literally get too much sensory input, so their muscles all contract at the same time and they lose control of their body. It's funny to watch, but it's really mean. So, same thing. I don't have any transformations yet, so I'm going to vertical asymptote at x is 0. So what, just quick sketch, what would that look like? We know that. What's different because it's a half to the x instead of 2 to the x? Start big, go small. How many people that was their plans for the weekend? I'm going to do all this cool stuff, and no, I'm just going to stay at home and watch TV. Okay. So the same thing is going to happen for all of my powers in logarithmic form. I still have that 1, 0, but now it's going to come at it from the other side. 2, 4, 8, 16 onward. Okay. I would like for everyone to find in their calculator where log base is. How would I actually type that into Y1? Because I see log, I see natural log. And a kid asks me, how do I type this? And I say, math. They think I'm being just a pedantic jerk. No, literally, in the math menu, there's a bunch of things it can do to a number. There's also different ways to type in a number. There's different ways to have complex numbers, probability, my fractions, and so on. What we're looking for is way down here, log base. Now, on a TI-84, you're going to be able to just type it as is. That's nice. Doesn't work out that way on TI-83s. You got to jump through some hoops. Okay, so I'd say log base of a half of x. Look at what happens to the graph. We talked about this with rational functions. You have to be smarter than the calculator. The graph does not just start at, oh boy, I'll see kids do that too. I'll see kids do this. Okay. You got to be smarter than the calculator. Know that this continues all the way up along that asymptote. I heard you. I'm going there. I wanted to finish that. I wanted to draw my line. So, option 1 is to go to math, log base. Option 2, because this happens so often, on TI-84, we get a shortcut for it. Alpha, the top row, gives me a bunch of shortcuts. So far, we've been using alpha y equals for fractions. We've been using alpha trace to bring up our y1 through y8 for our different regression models. If I hit alpha window, it brings up our most common functions. And one of them is log base. Okay? So the most common functions that you will use in math are included here. So I'd poke that and then type her in. Which also means that you can, if you don't know your powers like you're supposed to, you can also graph by points, plot by table if you want to. Oh, we didn't say the stuff. We'll just say it verbally then. I see this. Powers of a half reversed. 2, 4, 8, a half, a quarter, so on. If I see that, domain. 0 to infinity, parenthesis or bracket. Parentheses does not equal. Range. All real numbers. Continuity. No. How do you say the continuity? Because it is continuous. Not for all real numbers. Okay. My domain. Maybe we need to actually write it down. Domain range is going to be from negative infinity to infinity. X-intercept was at 1, 0. Y-intercept did not happen because there's an asymptote. In fact, I should write that. There's a vertical asymptote at x equals 0. That goes hand in hand with my domain. My continuity. It is continuous, but it's only continuous for the interval 0 to infinity. So here, I'd say continuous at 0 to infinity. It's continuous, but it's continuous here. You basically state it's continuous for its entire domain. Symmetry, none. Intervals of increase and decrease. Okay, as you go left to right across the paper, when is your pencil going down? Okay, the entire time. So we'll say from 0 to infinity, never increasing. And behavior, limit of my function, that's a g of x, isn't it? As x approaches, limit of my function as x approaches. So as I go all the way to infinity, this thing's headed down to negative infinity. Do you remember how we say the left end behavior? When I approach 0 from the right. That's correct. 0 plus as I approach 0 from the right. It goes to infinity. Okay. Now remember, different textbooks are going to say that differently. I do this because that's what Mr. Spear and I have always done, and I wanted to make sure that PreCalc was also aligned with how he does trig and calc. Okay, this is the way that I was taught, but if I remember right, our book will say the limit as x approaches negative infinity does not exist. But there's the two different schools of thought that your end behavior should be at the ends of your domain, not the ends of the real number spectrum. Okay. So, can you graph a thing? I don't know which one. We shall let the dice gods decide. Odd, even. Even it is. B. Yes, increase, decrease. Power of Christ compels it. Okay. You should just be using your powers of 3. 1/9, 1/3, 1, 3, 9. Just use your powers of 3, but they're on their side. And vertically reflected because it's 1/3 instead of 3 to the x. Stating all the stuff. Domain, well, you know what? All the same, right? It's almost like, until you start hitting transformations, these things have a particular set of properties to them. Ah, he did it again. Okay, there is a particular set of properties that these things will have. Oh, don't fall apart. There we go. Okay. They want you to think instead of just giving you answers. So, what I do want to point out, though, is the book does have as it approaches 0 from the right. Okay. If I remember right, early on, our book just said as it approaches negative infinity, does not exist. I think they wised up. That was probably something you were supposed to learn along the way that I just completely skipped over because I don't like our book. Transformations. Y'all know how transformations work. If you need the transformation form of it, maybe you put it down here. You got room. We're going to have y is log base b of excellent. What does A do? Vertical stretch and compression. You could just call it vertical dilation. I've forced the whole stretch compress thing in Algebra 2 in here if you want to just call it dilation and you understand that it's getting bigger or smaller. Also vertical reflection or reflection in the x-axis. I can't call it B anymore because that's our base. How about C? Horizontal dilation and horizontal reflection, but it's important to remember that it's always by the reciprocal 1 over C. Okay, so if there's a 5 right there, it's a horizontal compression by 1/5. Think about what happens to you're saving up for your car and we take your paycheck and we cut it in 1/5. Takes you 5 times as long to get where you want to go. Okay. H. What does it do? Horizontal transformations, and it is bass-ackwards land. If it says +6, you're going left 6. Also, plus K. Vertical translation, regular town. Okay, we beat the living crap out of that in Algebra 2. So, I'm just going to say, can you do the thing? Can you tell me what's what if I do the that and I do the that? If you can do those two right out of the gate, I think we're okay. Tell me the transformations to the parent graph. Graph it. Please don't say that.
I took the wrong one. Take one. Because if it was H, I'd be
Oh yeah, you're right.
so vertical transformation.
Can't fit any other point. Next point's 100. It's too big.
So excited we can do a gender wage gap discussion.
In the most mathematical sense of the word, who's your daddy? Parent graph is log of x, base 10. Okay. I'm going to take my normal point right here with vertical asymptote, and then we'll use powers of 10. I'm going to take that and move it down 1, 2, 3, 4, 5. How do I know it's down 5 and not right 5? No parentheses. If there's parentheses, it groups it in with the x. Now it's in bass-ackwards land. There are no parentheses, so it is a k value, not h. I will also reflect. So instead of going up and over 10, I'm going to go down and over 10. If you're going to be in here not doing the thing that we're doing, don't be interrupting the thing that we're doing. Okay, that's it. My two transformations were vertical translation, down 5, and a now what I will say is if I said it in this order, in there, if there was a word problem where it specifically said, take this graph, vertical translate down 5, and then reflect in the x-axis. It is not this graph. Because order matters. Addition and multiplication are not commutative with each other. If I were to vertically translate down 5, so, and then reflect in the x-axis, it goes up there. Okay. All the way back in Algebra 2, I hammered on this. I think I said it back in 1.5 when we reviewed transformations. This is why I prefer saying a vertical reflection, because I can reflect vertically about the point anywhere. Or, if you have a reflection at all, it's just best to say that first. And I think that was the rule of thumb we used back in 1.5. If there's ever a reflection, say it first. Okay? All right, the other one was Who's Daddy? Ln of x.
Yeah.
And then okay, so I'm going to take this point that is normally right here with my vertical asymptote, and I'm going to move this point down 2. Then I'm going to use powers of e, but my vertical spacing is going to be half as far. So instead of going up 1 and right e, I'm going to go up a half and right e, which is 2.72-ish. If, wait, right? Yeah. If I'm going to go up 2 and over e squared, then I'm instead going to go up 1 and over e squared, which is like 7.29-ish, I think. And then 1 over e is going to be itty bitty, and 1 over e squared is going to be even itty bittier. And you're going to see this thing hang a hard right at that point. Whoop. What happens is the bigger the base gets, the more sharp that curve is. Just like the bigger the base was on an exponential curve, the sharper it took off. So let's graphing them. Again, this is all review from way back when, so I'm assuming we're okay. Blah, 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 words. Ostensibly, they want us to move our formula around, use our properties to combine things wherever we can, but the end result is you're going to have to dump it in a calculator anyway. So, can you just figure out basic, like, word problem? Intensity level of a sound in decibels, measured by formula. W over W sub 0. W is intensity of sound in watts per square meter. And W sub 0 is a constant. If it's a constant, that means I know I can put it in my formula. The intensity of a person who is talking loudly. 3.16 times 10 to the negative eighth. So that's the intensity of my sound. 3.16 times 10 to the negative eighth. They said W sub 0 is this constant, 1 times 10 to the negative 12th. And then I've got randomly a 10 out front as well.
I have a question.
Oh yeah, that's a log and then a 10. What?
So in this, the log base is 10, correct?
Uh-huh.
Would anything cancel out?
See, that's what I mean by they want us to rearrange stuff, but you're going to have to break it up anyway and use a calculator. 10 log of that. When I don't see a base, what is the base? Okay. So I'll put that there just so we know, hey, it's common log. So what they're wanting us to do is 10 to the negative eighth over 10 to the negative 12th. Y'all remember what's the rule for dividing exponents of the same base? Subtract them. Yep, negative 8 minus negative 12, positive 4. So this now becomes 10 log base 10 of 3.16 over 1, so 3.16, times 10 to the 4th. Unless you know the property for splitting up logarithms, you just got to dump it in the calculator anyway, right? Not. We can't do that yet until we know the properties like this. Until we know the properties like that. And then all of that was to the 10th, so now this is to the 10th, so now this is to the 10th. So this is really log base 10 of to the 40th, so this is just 40. But even if I know all those properties, I still get this. I still have to jam it in a calculator. That's what I mean. So no matter what, even if you're able to simplify the expression, you still have to jam this thing into a calculator. So you might as well just jam it into a calculator. Y'all press the buttons. Either yellow or blue, don't matter. You're going to get the same thing. Sound in decibels. I got where is it? Oh, be quiet. Okay. What do you get? 44 and change. Okay. I'm going to go to, I got a thing. I'm going to send it to you. It's a decibel chart. And want to know how accurate you think it is. Come on, where are you? August. It was a long time ago. As we're talking about sound intensity. There we go. Shoop. Come on. Internet. Score. Okay, I sent you a little chart, and this is a comparison of different kinds of sounds and where their decibel level is. Where people think that, now this is based on surveys, where people think that it becomes uncomfortable or not. PreCalc. There's an attachment, view original. Shoop. Okay. So, the thing that we just did says a person talking loudly is at about 44 decibels. Well, depends what you define as a person talking loudly, right? I would guess that's what I'm doing right now. I'm trying to project to an entire room instead of sitting right next to someone. If I was talking like this while sitting right next to you, you would think I was talking loudly, right? So along this, theoretically, it says most people start getting uncomfortable right there. This was based on a big honkin' survey. Do you agree with that? Are you okay with a blender? A motorcycle? A mower? Okay. Allow me to introduce you to hyperacusis. I have to start wearing earplugs because it's physically painful. Okay. Imagine stuff that you're like, I don't care. But it's like being hit in the head with a 2x4. To me. Okay. These are all things that, like, at this point, it says uncomfortable feeling starts. Look at where your hearing damage starts. Like, consistent use of this results in damage to your ears. How many of you mow your own lawn? Use a snowblower, whatever, right? Do you use earplugs?
I started with this year.
Or earmuffs or anything?
So I've gone to a rock concert without earplugs.
Okay. To go to our staff meetings, just when they say, here's the thing, whatever, take 5 minutes, just talk to your neighbors. I have to turn on the noise canceling feature on my headphones just so it doesn't hurt. Imagine that level of sensory input every single day. Okay, that's what hyperacusis is. Imagine the damage that happens when you are not using hearing protection. How many of you have taken the shop classes? Do you actually use hearing protection in there?
No.
Okay. A grinder, like a metal grinder, it's above 110 because this is just the motor itself. This isn't the vibration of this grinding stone on the metal. Okay. So as we're talking about decibel and noise levels, I just wanted to bring this up because y'all, I got into the whole pain is just, the more pain you endure, the tougher you are kind of crap in high school, like every other toxic male. And I didn't wear hearing protection around the giant diesel engine behind my head. My ears ring all the time now. Like if I'm sitting in a quiet room, my ears are just at all times. Take care of yourself now so you don't go deaf later. No, they're not supposed to. If you're in a sensory deprivation chamber where you actually eliminate all sound, you should not hear any ringing. but over time you will start to hear your own blood pumping. You will start to hear your own heartbeat.
I mean, I don't hear ringing like very often, but like sometimes when I'm just like chilling there, like my ears just start ringing for no reason.
That's just
So, just letting y'all know, take care of yourself now, please. All right, the threshold. Okay, the threshold of hearing for a person with hearing loss is 5 decibels. This person has hearing loss. If you go below 5 decibels, they won't even hear it. So this is when you notice Grandpa's starting to have Wheel of Fortune too loud on the TV. Okay. Will a sound intensity of this much be audible? How do I figure that out? Plug it in. Grab your calculator, plug this in for W, and see if it comes out at 5 decibels or louder. So we'll go back here, say 10 log of alpha y equals thing. Oh, I didn't need an extra set of parentheses there. It did it for me. Log of, what was it, 2.1? 2.1. 2.1 times 10 to the negative 12th over, I want to point something out once I've finished typing all this. My constant, 1 times 10 to the negative 12th, 1 times 10 to the negative 12th, close parenthesis, womp. A, it's not above 5 decibels. They're not going to hear it. B, couldn't I just do 10 log of 2.1? I used ln. Oops. Right? Okay, so that's something that they kind of want you to be doing with these. But no, it's not audible to them. And they don't hear this at all. Sounds in excess of 85 decibels cause hearing damage. Determine the intensity of a sound with an intensity level of 85 decibels. So now they're telling me my decibels is 85. And we know that is 10 log of I don't know over, and I know my constant, 1 times 10 to the negative 12th. Option 1, left side y1, right side y2, monkey with the window until you find the intersection. 10 to the negative 12. What I would prefer to do here is solve using the definition of logs. Stage 1, I'm going to divide by 10, say log of W over, yes, 10 to the negative 12th, because it's 1 times, is 8.5. What could I also do with that 10 to the negative 12th? I divided by 10. Yeah, bring it upstairs. That's now log of 10 to the 12th times W is 8.5. How can this still get me my answer?
Wait. It's log base 10.
Uh-huh. If I know that this is base 10, I'm saying 10 to this power makes this thing. So 10 to the 12th times W is 10 to the 8.5. So I could divide and say W is 10 to the 8.5 over 10 to the 12th, but I also know my powers of exponents, or my properties of exponents. So I'll say W is 10 to the negative 3.5. or 1 times 10 to the negative 3.5.
That's only to solve for W. Then you have to go back and plug it in.
Well, it says sounds in excess of this determine the intensity of a sound. So it's going to be 1 times 10 to the negative 3.5. Well, wait a second. 1 times 10 to the negative 3.5? I can't. That's not scientific notation. So maybe I grab my calculator and I say 10 to the negative 3.5. And now it's in scientific notation. 3.162 times 10 to the negative 4th. Okay? Because all of ours were in scientific notation, so we should write our answer in scientific notation. Y'all remember that, right? Like this is times 10 to the... Please, oh please, if you're going to do it though, put approximately in front of it because we did cut off part of our answer. Believe me, I've tried.
I felt. Yeah, I feel like such a savage. Like wrote down an answer, and I was like, that's actually not true. I felt so bad myself.
Our science teachers are very flexible with how their answers are written. What usually happens is kids go through my pre-calc and then they get really mad at our science teachers. So. All right. So blah, 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 blah. There's a formula. You can use a formula. Like, yeah. Okay, just cross it out. Yay, properties. So we're going to get a jump on this because what I think I can do, I know we're not going to get all the way through 3.3. Not even close. We're going to start 3.3. We should be able to finish it and start into 3.4 tomorrow. If we can finish 3.4 on Wednesday, that'd be perfect going into a quiz Thursday. Okay? Wait, is yours on Thursday or Friday?
Friday. Thursday
One.
last week.
Oh yeah, it would be on Friday. Well, that means no homework for the weekend, right? So, yay. All right. What do you mean sleep? You didn't do your pre-calc until last night.
Nope, I didn't even do it. Some.
All right. Couple of properties of logs. If I multiply two exponents with the same base, what do I do to the exponents themselves? Since logs are the inverses of exponents, that means they're going to have properties that are very similar. If I take the log of a product, I can write it as two separate logs being added. I said, we've done all this before. If I can have x to the a over x to the b and turn it into x to the a minus b, likewise, if I have log of a quotient, it becomes two separate logs with a difference. And then our power property tells me that my exponents on the object of the log can become coefficients, and my coefficients can become exponents. Okay, they can go in either place because I'm talking about a base to a power. So if I multiply it by that power, well, it's the same as the exponent being increased by 1. So they're very, very similar. They're very related. This allows me to start rewriting logs like this. Right now, if I were to ask what is the ln of 54, you'd just be like, nah, calculator. Okay? But I can rewrite that in terms of ln of 2 and ln of 3. The first step is prime factorization. Do you remember how to find the prime factorization of a number? Factor tree, old school. What times what makes 54?
1 times 54.
6 is 5.
Okay.
Yeah, I thought my answer was pretty funny. I was able to be wrong.
So the natural log of 2 times 3 to the third. First things first, I'm going to write the prime factorization of it. Always start there. Next, I see a product. Log of a product becomes the log of, or 2 separate logs as a sum. So I turn this into the ln of 2 plus the ln of 3 to the third. One more step I can do. Exponents can become coefficients. The ln of 2 plus 3 ln of 3's.
I forgot about that.
You did say that.
You put it up. Yeah. And then it's get down. You put it up.
Okay.
Yeah. You remember that? Yeah. I was scared. Who was it?
I don't know. I don't know.
It's really good at it.
So I don't know.
Then,
Can we get an explanation of that?
Boy, what
Okay,
the-
so like if you have ln 3 to the third, it's in the chopper. Get down, put it in front.
And then do it.
And then you say what you say. What if it's in the front? You can like get in the chopper.
Yeah.
You know?
I mean, I understand the reference because I love Predator, but
I know what that's from. I just didn't get
okay. So anyway, 9 can be rewritten as what? 8 can be rewritten as what? So if I have the ln of 3 squared over 2 cubed, it's the log of a quotient. I can rewrite it as a difference of logs. So it's the log, natural log, of 3 squared and the natural log of 2 cubed. But then I have exponents that can become coefficients out front.
I sound stupid.
My attempt at a Schwarzenegger impression is really, really bad, so I just don't do it. So, ta-da. Okay. The important part is you have to break it down into prime factors before you even start trying to move things around. Now, I know you can do that with 75. I want to see if you can figure out common sense, what is what, with 5.4. Do both. But I want you to argue about the second one.
0.5. Got you there.
How could I possibly rewrite that in log 5 and log 3?
10.
Literally anything. True. It's only 2 paragraphs.
What are the factors of 5.4? What can multiply?
It's literally not.
Well, maybe the third line shows divided by 5.
It's a fidget spinner, but only a single gear, so it's nice and discreet.
Oh! Log of 3 to the third divided by 5. Like that.
Yeah, but how'd you get there?
Because you showed me that it's 3 to the third and 5.
How does that equal 5.4?
Wait, so
Because
that's
3 to the
9.
third divided by 5 is
27 over 5.
Okay, how'd we get there? How did we turn 5.4 into that?
It's just factors. You just gotta know your math.
You gotta know your math. What?
Oh, that's 3 things. That's cool. I don't know.
I'm guessing the first one, fairly straightforward. What place value does 5.4 go out to? So if it's 5 4/10, isn't that 54/10?
I got 54 tenths, so I was like.
Which reduces to 27/5. Okay. Note to self, if I see fractions or if I see decimals, write them as a fraction. Fraction, good. Decimal, bad. Okay. But once we see that 27 over 5, we're okay.
Yeah, I was on the right track, but I like did it a little bit way.
You hear that, bro?
I don't know why.
Just starts making random noises. Okay.
I like seeing on a
Same.
Then I have
Right now, this is asking 4 to what power makes the 5th root of 64?
What is
Well, 2 to the 6.
So if I'm saying 4 to what power makes the 5th root of 64?
Can you just rewrite that as 2, 8 squared,
8, 5 halves.
Can you rewrite that as 4 to the 3 fifths?
Because 4 and 64 share a base. I can either write this as 4 to the x is 64, isn't that? Is that 4 to a power? So 4 to the third fifth root. And if you remember rational exponents, now I'm saying 4 to what power is 4 to the 3/5? Common sense tells me x must be 4 or 3/5. Also, I could keep going. Turn that into 2 squared to the x. And turn that into 2 to the 6th fifth root. But if I do that, well, now I just have 2x must be 6/5. Divide by 2 and you still get 3/5. So you have to remember how rational exponents work. Good thing this is the 3rd or 4th class you've seen it in. Ruh-roh. If I've got something in exponent land, it can come out front as a coefficient. I now have 10 Lennies minus 3 Lennies. But wait a second, what is the natural log of E?
1. Yes.
Okay. Properties of logs do good stuff for you. So the very last thing, finish this off. I'd say we're there. Finish it off. Okay, part B. Fun way you can do this, remember, whenever the base and the log are the same. So you can just get rid of that. The base of the log and the base of the exponent are the same. Okay. Logs are not difficult. You just got to get used to how you swap things in which direction.
They are. I think it's fun.
I gotta go watch a baby do one.
And it will forever change your